Good afternoon and happy Monday. This is Mr. Gruber. I'm actually recording this on Thursday, but you're not going to watch this till Monday, and I won't post it till Monday. This way, you guys hope you had a good Easter weekend. I hope you had a great Passover. It's time to get started on Waves. Let me tell you something. Waves is going to be a lot of fun, but there's so many things to show you. It's a good thing I took a lot of videos in class, and let's hope you get something out of it. I think Waves is amazing. It's a lot of fun. It's easy to do. I have my Wilson here. He's sitting on Coroni, taking care of him. All right, Coroni. Turn it off so you can see. All right, so Coroni, are you ready for today's lesson on waves?
I don't think so.
It's going to be good. It's going to be hard showing you some of this stuff. I'm going to try my best, jumping around between different apps and stuff. So let's get this party started. Let's get right on to waves. Good thing is you already started with the first demonstration. I don't know if you read the first section here, all right? When it talks about what we wave, bye-bye to mechanics, and study different topics in physics. So you guys can read through that. There's a lot of cool things we're going to see in this topic called waves. Now, the first thing you did to actually be introduced to the topic was you built a classic soup can telephone. Let's change my color. Should have had this ready. I'm sorry. Go with red here. Go with let's go with this, like this blue here. Make it a little thinner. All right. And then over here, crayon. We've had some complaints about the crayon. I will not use crayon. I will use this purple here, or fuchsia, or whatever, pink. All right. So, first thing we're going to talk about here is the classic soup can telephone. Now, you just built one of those, but what did that teach you? Well, here's the question that some of you did answer, and it was, how does sound get from one can to the other, right? And did anyone try this? It said to let the string, hello, give me a color, come on, let's go. It said let the string or spring. Now, of course, the one I have in class looks like this. This uses a spring and has a really cool sound. No, we can't do that because we're not in class. So it was let the string touch your hand while someone talks to find out. Did you do that? If not, go try it with the soup can telephone. Have someone yell and touch the string while they're yelling. And here's what you'd find out. Something very, very interesting as this. All right? Sound is traveling through the string, but we haven't defined it yet. So we'll get to that. See, it turns out the actual answer, don't worry about spring. All right? Sound is traveling as a wave through the string. Now, I don't know if you felt it. Hopefully, if someone yelled in the other cup, you felt that vibration, right? And if you pull the string tight, if you didn't do this, go try this. Pull the string tight, have someone yell in the cup while you hold the string near your end, and you'll feel that string vibrate. It's pretty dang cool how that works. So go try that. Pull the string tight, have someone yell in the cup on the other side. You hold the string with your hand and see that you feel that vibration in your fingers. Actually, not when I'm saying. Let me go to screen. Go to video. It's on front. Hold on. All right. So what I'm saying, if you have a string here, I'm going to use don't have a string. All right. So I have a set of beads here, rosary beads. So here we go. So you got your string here. While someone's talking and you got this thing hooked up to your ear, hold it like this. Hold it there. And when you hold it there, you should feel the vibration in your hands. That's kind of cool. Let's get back to this. Okay. So now, a lot of people were confused by this second question, but you guys did a good job because some of you did it. You had two ways to interpret this. It said, if you notice, it says, what happens to the sound when the string is held tightly? Now, what many of you thought that meant was pull the string tight, and that's perfect. But here's what I want you to try, all right? I want you to have someone talk, right? And then I want you to squeeze that string tightly with your fingers and tell me if you hear sound coming into your cup. Go do that now, and then come back. Hey, welcome back. So when you held that string, while someone on the other side, when the other cup was yelling, and by the way, if you don't have someone else, and I should have said this before, you could use that spoon demonstration a lot of you guys did. But did you hear sound in your cup when you held that string tightly? And what you should find out is that you did not, right? you should find that the hand, and here's a new word that we're going to talk about, the hand absorbs the sound, right? And here's another new word, because a lot of vocabulary in this unit. The sound wave is no longer, and here's a word, it starts with a T, it's called transmitted. I will get to all these words as we go through. You can't answer number 3, which medium is a better transmitter of sound, so we will just leave that because we don't have any basis for comparison. You know? Unless, did anyone build their cup, their soup can telephone out of a metal string? I don't think anybody used metal, so we can't answer that one. Well, let's get right to the definitions. Let's scroll up a little. So the important definitions we got to deal with in this unit. Again, I'll just cross this out. We got to define this thing called a wave. So what is a wave? Right? A wave is the periodic motion of a medium, yet another new word, caused, and here's the important thing, caused by a transfer of, very important word, energy. Make sure you highlight that word, energy. Period of motion of a medium caused by a transfer of energy through the medium. All right? This results in the medium oscillating. Now, that word is a pretty big word, but I'm going to write over here. We can use other words for that. All right? Let me put that in. Okay, we could say oscillate equals, hello, come on, vibrate. Oscillating up and down, the same as vibrating up and down. So the medium oscillates up and down or side to side, all right? Now, this note is very important. Waves transfer energy only. They transfer energy only. And you should add a disclaimer there. All right? All right? Put that over here. They do not transfer mass ever. Don't forget that note. I'll be checking for that note in your notes when you submit these. They do not transfer mass ever. Okay? So we'll get to waves in a second once I finish up these definitions. Next one is this thing called a pulse. Right? A pulse is a single disturbance, all these different words, or vibration, a single vibration, not multiple vibrations. All right? A single vibration. So let's kids forget that word. I don't want to use that. A single vibration. I like that better. A single vibration. So we got wave now defined. Wave is defined. Pulse is defined. Now we got to define that word medium that we saw several times in the definition of a wave. What is a medium? Anyone know? Anybody? Corona, you know what a medium is?
Unfortunately not.
Anyone know what it is? Okay, say it out loud. I can't hear you, but you can always say, yep, I got it right. Did you get something that sounds like this? It's the substance or material through which the wave or pulse travels, right? You might have heard of a medium. Was it Long Island medium? John Edward? You know, these psychic mediums, right? Medium, right? A psychic medium is a conduit through which spirits from the other world talk to the living, right? Notice, spirits from the other world talk through the medium, right? So the information passes through the medium. Well, that's what a medium does. A medium allows a wave to travel through it, right? You could also say a medium transmits a wave. I don't even write that, right? Like a lot of people use like they'll say a radio antenna transmits. No, a radio antenna emits. The medium transmits a wave. Medium transmits waves. Or can. All right, so that's what the medium is. So let's show you this. Let's see, where are we? Give me a second. Other apps open. Let's see, what do we have? This is good. Oh, I like this one. So let's see. Well, I just had it searched. Come on, see what I mean? Had them all lined up. Here we go. Okay. Let's start off with a water wave. What a perfect thing to do. Start off with water. So let's look at this from, we can look at it from the side. Kind of easier. Come on, look at it from the side. That's not the side. That is not, that didn't click. Here we go. Now we got the side view. Okay, so let's send a wave by having vibrations having every couple of seconds. So watch this. Okay, there we go. So here we have our periodic wave. And what you'll see is the surface of the water is oscillating up and down as drops of water come out of the faucet and force the water to vibrate up and down. Right? So that's your periodic wave. And that's not to be confused with let's keep it at side view, a pulse. So let's clear that out. And here's a single pulse. Ready? And drip. There's your single pulse. That's a pulse. Here's another pulse. Right? Blip. Right, there's another pulse. Good, yes, no? Okay. So the medium in this case, what is the medium? Corona, you know the medium?
No.
The medium is water here. All right, let's show you another one. This one's a cool one. I like this one. All right, so here is it looks like a bead necklace, right? But let's not have it fixed end. Let's have it have no end. So this bead necklace goes off into infinity. You can see mountains in the background, so it just goes off into the mountains. I'm impressed that this bead necklace can stay perfectly level and its own weight cannot weigh it down. So we can send a single pulse through it. Pulse. Bipulse. We could send in oscillation through it. So there's your oscillation while this thing is vibrating it up and down. So that is a wave. What you're seeing right now, that is a wave. Let me get rid of damping. I don't want anything to happen to the wave height. So there is your wave. Here's your pulse. Right? Wave. Pulse. There's your single vibration. Here's your periodic vibrations. Okay, so get that straight. That is your wave there. The medium here, what is the medium? Well, the medium is this bead necklace, this really long bead necklace. That's your medium there, okay? So we got down wave, we got down pulse, we got down medium. And again, what is the medium doing to the wave? The medium is emitting it. Is it emitting, Coroni?
No can do.
You got that right. No can do. The medium doesn't emit, the medium transmits. So let's transmit a pulse. Now, this little oscillator, this thing I can't draw, that little thing with the little green button, that's going to emit a wave. Boom. And then the bead necklace transmits it. Okay? Over here, when we were doing this, in our water wave container. In our water wave, okay, look at it from the side. Okay. This drop of water is going to emit waves, and then those waves get transmitted through the water, the medium, which is water. Okay, so far so good. Hello, let's scroll up. Good. Let's go back to the notes. So we got medium transmits waves. Let's go on to the next page. Boom. All right, a lot of different notes here. It's really what this whole section's about. This is all about, a lot of this is vocabulary. The whole next couple of pages is all vocab. So for you, the guys that like vocabulary, you're in a good place. So we have to classify waves. Now, if you look at pages 2 and page 3, you'll see there's an A and a B because we're going to pick two ways to classify waves. So on page 2, the first way we're going to classify waves is based on the motion of the medium. All right, so how does the medium move is one way to classify waves. Now, on the other page, if you go to page 3, the other way to classify waves is based on the type of medium. So notice the difference. That's page 3. if you missed this, you can go back. Don't worry. So on page 2, we're going to classify waves based on the motion of the medium. And on page 3, we're going to classify waves based on the type of medium. Subtle difference. There's other ways to classify waves, but in Regents, we classify them 2 ways based on that. Okay, so doing these together, the first type of wave based on motion of medium is going to be something called the transverse wave. Transverse waves. Okay, so transverse waves are one type of wave based on motion of medium. Right? The other type is called the longitudinal wave. So we have the transverse waves and we have longitudinal waves. Transverse waves and longitudinal waves. Right? So what's the difference? I want to do them together so you can see how this works. So a transverse wave is where the motion of the medium is perpendicular to the direction of wave motion. Right? So the motion of medium is perpendicular to the direction of wave motion. Right? Perpendicular to the direction of wave motion. I'll demonstrate that to you. All right? A longitudinal wave, the motion of the medium is parallel to direction of wave motion. Okay? So get that stuff in your head right now. Transverse wave, motion of medium is perpendicular direction of wave motion. Longitudinal wave, motion of medium is parallel. Now, a nice memory trick here is, hey, look at this. A transverse wave starts with a T. Oh, and T is an upside down perpendicular sign. Ha ha ha. Look at that. Look at that. Okay. I don't like the way that looks. Do that again. All right. So a T is an upside down perpendicular sign. Now, notice in longitudinal waves, you got an L and an L. Ooh, an L and an L. Parallel lines. Look at that. Longitudinal has 2 L's, parallel. Okay. Let's demonstrate this. We just looked at it already. We can go back and look at the motion of the wave here. Now let's go back to my VII. Okay, so let's take a look at the wave on the string. And we could do this in slow motion, which is really cool. Slow-mo. All right, so now watch. Let's send this awesome. Beautiful. Look at that beautiful oscillation. Okay. Now the wave, we want to go with no end. Let's, no dampening. Let's restart. Okay. Now you'll notice the wave is moving to the right from the oscillator on the left out the window. Okay? So the wave is moving to the right. Right? Wave is moving to the right. Get that straight. Wave is moving to the right. You'll see those humps moving right. Yes, I do call those humps. The humps are moving to the right. But now I want you to focus on and I'm going to screenshot this. Let me screenshot this. Hold on a second. And let's go to screenshot. No, the thing is moving. Give me a second.